In this video, we're going to learn all about Kubernetes pen testing. We're going to learn about AWS. We're going to do some web app attacks. We're going to do some network pivoting. We're going to cover a bunch of things in this video. And I do want to be clear, this is going to be a little bit different than my normal videos, and would love to hear your feedback about this in the chat. So if you find this method helpful, let me know in the chat, or if you hate it, let me know in the chat as well. But if you're new to my channel, what I generally do is I go through different labs live and I show you my full thought process. Am I struggling? But here's the thing, I also do labs offline. I'm always trying to learn and grow myself, even when I'm not on stream. And I thought, hey, when I do labs offline, then when I jump on stream, rather than just doing them again and kind of death by text or death by PowerPoint, maybe I can use that as an opportunity to teach through the lab and teach you the content a little bit better, kind of naturally in my own words, and in a way that might be a little more helpful to you. So that is exactly what we are going to do, but this is truly an experiment. So if it goes terrible, have mercy on me and let me know in the comments. But we are going to learn all about Kubernetes pen testing, AWS, web app pen testing, network pivoting. There's a lot of things this lab covers, and the lab that we are going to do, just to show you this right away, is exploiting exploiting Kubernetes overly permissive RBAC. Say that 3 times on Pwned. Now, as we dive into it, I do just want to show you this lab, and I want to be upfront. This is a premium lab, so you can only follow along with me if you have a premium sub to Pwned, but if you don't have a premium sub, you should go get one. Pwned is kind of like Hack the Box, but for the cloud. They have hands-on labs, both blue team and red team, covering AWS, GCP, and Azure, as well as a Thunderdome, a red team network, and they're going to be coming out with more of those. I've talked about that in previous videos, so you can check out those videos, but overall, this is an incredible platform, and you can get an yearly subscription for only $200 for the entire year. Crazy. But this is a recent lab that I really enjoyed. I want to give a shout out to Hack and Nefos over on chat right now. They are the co-authors of this lab. And right away as we get started, I want to show you Hack's YouTube channel. So I don't do sponsored content. This is not sponsored by Hack in any way, shape, or form, but I really do enjoy his content. And once again, Hack, thank you so much for helping make this lab. But Hack has a YouTube channel right here. I will drop it in the description of this video, but I will also drop it in the live stream chat right now. That should come through. There we go. But Hack creates a lot of the labs on Pwned, including, I think, all of the GCP labs. But just looking at his YouTube channel, if we go to videos here, I want to show you everything he covers. So he has detailed videos on GCP pen testing. He has detailed videos on passing the CPTS and sharing his experience. He goes through some of the Hack the Box Pro labs. Just does an incredible job at making content. So if you have not subbed to Hack over on YouTube, check him out. Check out his content, sub, and let's show him some support. But here is the lab that we are going through, exploiting Kubernetes overly permissive RBAC. We're given a little bit of a starting point, but here's the thing. We do have some prerequisites that I would recommend you know before we dive into this lab. If you don't know them, I'm going to do my best to kind of explain the prerequisites for you. But here's the thing. Number 1, basic Linux knowledge. We're going to do this entire lab, this entire kind of mini course using Linux, specifically Kali Linux. Now, if you're brand new to the Linux world, that's okay. You can still watch this. I'm going to do my best to explain anything that might be confusing, but basic Linux knowledge would be helpful for this lab. The second prerequisite is an understanding of Kubernetes. Now, Kubernetes itself can be confusing. I will define it for you and we'll explain a little bit about what is going on in the background. But honestly, even if you don't have a basic understanding of Kubernetes now, you will by the end of this video. And then finally, just a familiarization with containerization, which goes with Kubernetes, and web attacks. The initial entry point on this is going to be some good old classic web app pen testing, and I will guide you through how I found the initial attack vector and show you some things to look for in the real world, whether you're doing a bug bounty or a pen test. So let's begin. What exactly is Kubernetes? Well, Kubernetes is often abbreviated as K8s, and I'll try to throw this up on the screen in the editing, but it's an open source platform that automates the deployment, scaling, and management of containerized applications. I like to think of these applications like almost like VMs inside of your VM. So if you think about a virtual machine for just a moment, whether you use VirtualBox or VMware, right now I'm using VMware. My VirtualBox, my virtual machine, does not affect my host system. It is containerized within VMware. Well, Kubernetes and containerization is kind of like that. Containerization is taking an application and containerizing it so it almost runs on its own, whereas Kubernetes is kind of like the manager. It manages all these different software, ensuring the applications run smoothly. We have master nodes, we have child nodes. We're going to talk all about that, but that's a really high level overview of Kubernetes. But you'll recognize that Kubernetes is used widely, especially in the cloud. So if you're interested in getting into pen testing, especially cloud security, Kubernetes and Kubernetes security is a really good thing to understand. So let's go ahead and dive into this lab. One of the most important things that you can do is take notes. So I will show you guys my note-taking process. I like to use Notion, but honestly, it's less important what platform you use and just more important that you take notes. So here we are. Here is my Notion notebook, I think would be the right name. And I'm just going to create a new page inside of my Cloud Labs right here, and we will call it by the name of the lab. So here it is. I'm just going to copy that, jump back over to my notes, and we will paste it in there. I'm going to make it full width, and finally, we will make it full screen. So we have our note set up. This is actually the same way I set up my notes for pen test, for bug bounty, using Notion. So if you aren't already in the habit of taking notes, you should take notes. So let's go ahead and do this. Exploiting Kubernetes overly permissive RBAC. Let me jump over to this. Our starting point, we're given three things: a web server IP, EC2 credentials, and a compromised EC2 IP. Now, if you're new to AWS, there's already some terms or language that's going to be unfamiliar to you, specifically this term right here, EC2. Now, EC2 is confusing. AWS itself is confusing. So as soon as you get into AWS, you'll realize that they enjoy making names for things that should be basic, but they make it sound confusing based on their names. And that is exactly what EC2 is doing. When you see EC2, I want you to think virtual machine. All an EC2 is in AWS is a virtual machine. So right now, I am running Kali Linux as a virtual machine. Well, if I ran Kali Linux in AWS, which I actually do, it's possible, that is an EC2. It's just a virtual machine in the cloud. So we have a compromised EC2, we have EC2 credentials for the compromised EC2, and we're given a web server IP. And let's go ahead and read through the scenario of this lab. Our company has been hired to perform a pen test on a new client's digital infrastructure. After some initial reconnaissance, you discover that you have access to an EC2 instance with compromised credentials. This instance might serve as a gateway to the Kubernetes environment. Your mission is to leverage these creds, explore potential vulns, and exploit weaknesses in their Kubernetes setup to ultimately gain root-level access to their servers. And looking over the chat, John said, if you want to help, shouldn't the labs be free? So, John, I don't work at Pwned Labs, but here's what I can tell you. Cloud is not cheap. It would be impossible for Pwned Labs to host this in the cloud for people to do for free. Like literally impossible because of the cost. But Pwned Labs has over 40 completely free labs that you are able to do. But yeah, I don't run or own Pwned Labs. But it would be impossible for them to host this for free. That's just part of the cost of education at times. But it's also super affordable. Anyways, we are given three things: our web server IP, EC2 credentials, and our compromised EC2 IP. And what I like to do is already add this stuff to our notes. I like to begin, though, with our scenario. So I'm going to go ahead and copy our scenario right here. We'll jump over to our notes, and we will make an H1 header, and we'll just call this our scenario. And we will go ahead and paste it in there. So we have our scenario. I'll zoom in a little bit so it's a little bit easier to see. And now let's go ahead and do our credentials as well. We'll jump over to this, and what I like to do with credentials is to make a code block. You can do that in Notion by using the backtick 3 times like this, and we'll go ahead and create a code block for us, and we'll say our web server, if I could type IP, let's go ahead and paste that in there. We can grab our EC2 credentials, and we'll paste that in there as well. And finally, our compromised EC2 IP, and we'll just say compromised, I can't type. There we go. Add pentest to your dictionary. All right, fine. I will add it to my dictionary, and we can add RBAC to our dictionary. There we go. So this, I also want to make text, not Python. But there we go. There's our starting point. We have a web server IP. We have EC2 credentials, and we have a compromised EC2. So step number 1, let's just begin with our initial enumeration. We have 2 things that we can enumerate: a web server and a compromised EC2 that we have compromised. So I'm going to go ahead and we'll make a tab here. We'll just call this web server enumeration, and we're going to begin enumerating this web server right here. Now, there's a few different ways that you can approach this. We're going to use a classic tool called Nmap or Network Mapper. If you are new to pen testing, new to security, what Nmap will do is it will take an IP and it will say, hey, here are the ports or the services running on this IP that might be an interesting attack vector for our purposes. So the way we can do that is we'll go ahead and copy this IP. I'm going to open up my terminal here, and I'm going to create a directory for this lab as well. We'll just call this, we'll make directory Kubernetes RBAC, and we'll go into that directory. And now we're going to run nmap. And the syntax for that is we'll use nmap. We could scan every port like so, and that will scan all 65,000 plus ports. If you don't include that, it will only scan the most common ports. Generally, if you're doing a pen test or a CTF, you want to include the -p- flag so it hits every single port so you don't miss something running an uncommon port. But I do know from this lab we aren't looking at any uncommon ports, so we'll just do nmap without any of those special flags, and we can go ahead and do -a. What -a does in nmap is says, hey, I want you to throw all of the enumeration scripts at this IP. Let's see what is running on the different ports. Actually, I'm going to correct myself. Before we do -a, let's just run a regular nmap scan to see what ports are open to speed it up. And then when we know what the open ports are, we'll run a second nmap scan that then enumerates a little bit deeper. So we'll just do nmap like this, paste in the IP, and I'm going to do T5 because YOLO. That just means I want you to go as fast as we possibly can. And we'll do -v for verbose mode because I'm impatient and I want to make sure nmap is actually doing its job. So when we drop that in there, right away we see two ports that are open. We have port 22 and port 80. And we have a bunch of things that are filtered that we can ignore. But we have SSH running on port 22, and we have HTTP or a web server running on port 80. So now that we know our open ports, let's do a little more targeted scan to enumerate those open ports. We'll do that with nmap. -p, we're going to pass it the ports that we're interested in. So we're interested in ports 22 and 80. -a to throw all those enumeration scripts at it that I talked to you about. We'll drop in the IP, and we will do -v for verbose mode and go ahead and hit enter. Take a drink of water. Hey, see you later, teraflops. And now we have a little more information on the ports that are running, and we should drop this into our notes. So let's go ahead and copy this right here, and let's jump back over to our notes here. And underneath web server enumeration, I'm going to do an H2 header, and we will call this nmap scan. Drop it in a code block, and we'll change this over to bash. There we go. And I do want to show you guys another cool thing that we can do right here in Notion to keep ourselves organized. If we do /table of contents, it will create a table of contents for this lab. So then very quickly we can like look at what we're doing. If I want to jump down to the nmap scan, I can click it and it will drop me down to the nmap scan. But we have the nmap scan right here. We have port 22 open. That's not going to be super helpful for us yet. It might be if we're able to get credentials, but we do have a web server open on port 80. But let's go ahead and also enumerate our compromised EC2. Like, let's make sure we can authenticate to it and see if there's anything interesting on that. So we can do H2, well, H1 actually, and we'll just call this compromised EC2. And I want to grab it from up here again. We'll just have it down here as well, so it's easy to access. And let's go ahead and just see if we have SSH access to this compromised EC2 with the username administrator. So I'm going to copy that IP. We'll open up our terminal where we were at before, and now we want to use SSH or secure shell, which is going to give us a command line interface on this remote computer. So we'll do SSH administrator, and we're going to drop in the IP of that machine like so. We will click yes, or rather type yes, and now we need to grab the password, which is right there. Go ahead and copy that, jump back over to this, we will paste it in and enter. And then you cross your fingers and you hope it works, and it does. So we do have full SSH access to this machine. as the administrator. We can sudo over to root, it looks like, if I paste in the password again, and now we have root access. So we have that information. We go ahead and grab this for our notes, and we know that we have SSH access. We'll grab that, drop back over to our notes, and we'll just say H2 SSH access confirmed. And we'll drop it in there. So we have root access, we're the administrator, so that EC2 is fully compromised. Now, looking at this, I'm going to drop this down because we're going to continue to enumerate this web server right here that we hit with our nmap scan that we have running on port 80. Now, we can use various tools to use this. You can use OWASP's app, you can use Burp Suite. I personally prefer K8s, so that is what I'm going to use, or it's actually pronounced K8s. I realize I've been saying it wrong this entire time, but it is pronounced K8s. Now, the reason I use K8s is it's more affordable than Burp Suite Pro, but even the free version of K8s, in my opinion, has more features than the free version of Burp. Specifically, you're not rate limited on intruder attacks. So I enjoy K8s for that purpose, but we'll go ahead and open up K8s here, and we'll start our local instance. And we'll go ahead and create a project, and we'll call this Kubernetes RBAC for our project, and I'm going to create it. We'll go over to Intercept and open up a web server here. And we'll just close this extra window. And now we can go ahead and begin enumerating what might be on that web server. So let's jump over to our notes, like so. And we will grab this web server IP there. And let's see what's on there. So we have sold out master. We never go out of stock. So we have a few different concerts that are in play, but let's go ahead and take a screenshot of this. Now, the tool I like to use for screenshots is something called Flameshot. So let me go ahead and open that up on my Kali instance, and let's take a screenshot. There's my phone telling me I should live stream, which I'm already doing. Let's take a screenshot of this page just so we have it for our notes. So I like to get at least the IP in there and the main host right there. So we'll jump over to our notes, and we'll just call this one web app enumeration, and we'll paste in the screenshot like so. We can probably make it a little bit smaller though. We don't need it that big, and left align it. All right, let's jump back over to this. So let's see what functionality we have. We have view details on a bunch of concerts. We have concerts up here, about us, and contact. So we can look at a few of these. So if we go to concerts, we're able to search concerts. So we can say like Hack Smarter than the Hack Smarter concerts going on, and there isn't, right? We could say like concert, and we're able to see there is at least one concert there. If we go over to the About Us page, we have About Us, the unbeatable ticket sellers. At Soldmaster, we pride ourselves on providing concert tickets that are practically free. Not really, but almost. We guarantee that our ticket prices are so afforded that you'll wonder if it's a joke, but trust us, it's real. Sort of. Our service is rock solid. We've engineered it to never go down except for scheduled maintenance every once in a blue moon. Security, oh, we got you covered. Our systems are so secure that even the hackers give up before they try. I mean, not that anyone would try, of course. And remember, our tickets never go out of stock. We have an endless supply because we've mastered the art of never running out. Because even if we do, we'll make more somehow. So why wait? Browse our concerts. Grab your ticket now. You won't find a deal like this anywhere else, or maybe you will, but you won't regret choosing us. Amazing. So there's not a whole lot of functionality here. Is there a contact page? That goes nowhere, but we do have this contact page. So let's just pick the best concert because it's not planet Earth. So maybe it's Mars. I don't know. I think someone joined the chat from Mars earlier. So let's go ahead and go to this one. Not planet Earth. The performer is Taylor Drift. I think I've heard of that person. Come and enjoy an out-of-this-world performance by Taylor Drift, the smoothest artist in the galaxy. Ticket price free if you can find the venue. So let's go ahead and buy some tickets, ladies and gentlemen. We have some information here. Please don't enter real credit card data. You can enter any fake card number to continue. All right, thank you. So our card number is 1337. Oh, if I can turn on numlock, 1337, 1337, 1337. Our expiration date is 1337, and our CVV is 1337. Now, what I like to do just in general web app stuff is monitor all the requests when I do things like that. So we can turn on queuing real quick and we can hit pay. Now, if we jump back over to Kaido rather, we can see what is going on here. So it's doing a post request to buy one. Now, if this was a web app pen test, we could try IDOR on something like that. We have our card number, expiration date, and our CVV that it's passing. We'll go ahead and forward that request. And now we have another GET request for a ticket form 1. And we have a session right here, which might be an interesting thing to keep in mind. Once again, this is a real web app pen test we are doing. I want to look to see if there's any IDOR possible with that. But let's go ahead and forward that request. That's just a general field. And we'll jump over to this. It says, generate your ticket for the best concert. My name is Hack Smarter. So let's go ahead. We have queuing still on, and let's click generate ticket. So we have a post request that passes our name to it. What I'm going to do is I'm going to send this to what's called replay with Control R on my keyboard so we can replay this request over and over again and see what responses are going on. I know CVV is 3 Zmur, but my CVV is 1337 because that's how lead of a hacker I'm in, and it let me do it. So we're going to go with it. Let's go ahead and forward this request on. And nothing happened there. If we jump over to this, we have an insecure download block, but we're going to keep the insecure download, and we are receiving a concert ticket as a PDF. So let's open this up. And I want you all, before I tell you, for those of you watching on stream, feel free to shout it out. I don't know why the chat isn't pulling up on stream right now. Let me see if I can fix that. There we go. I think I fixed it. But when we look at this, what stands out to you? What do you guys think we should try? If you're watching on YouTube, I want you to kind of pause the video and think about that for a second. I'm going to take a drink of water and then come back to it. All right. So if you're learning web app pen testing, here's what should stand out to you immediately. These are things I see in the real world when I'm doing pen testing. If we look over at the request here, it's passing it a name right here, and this name is being added into a PDF. There's a few different things that we could try. We could try HTML injection. We could try server-side cross-site scripting. I think that's the correct term. We could also try server-side template injection. Now, if you didn't know to try those things, if we jump over to Firefox, we could even type in like PDF generation exploits. I bet it would come up what we're looking for. Right away, we have SSRF bugs, exploiting PDF generation vulnerabilities, server-side cross-site scripting, malicious PDF generator, PDF injection. I mean, a lot of different things that we could try. And when I see PDF generation in the real world, these are all things I try every single time on a pen test. So let's go ahead and try some of them. I don't think we're going to be able to see the response here. We probably have to do it via our interception over here. But let's jump back to this and let's just try some basic HTML to see if that does anything, right? So please subscribe. We'll throw in an H1 tag and we will click generate ticket. And you can see it did not include our HTML, so it may not be vulnerable to any type of HTML injection or cross-site scripting. The other thing I always try on a PDF is what's known as server-side template injection. One easy way to check that is with this 7x7 payload. If it's going to be vulnerable to this, it's going to give us the answer to 7x7, 49. If it's not vulnerable, it's just going to print this input. So let's go ahead and try that. And you can see we have 49. So that tells us this PDF generation process is vulnerable to server-side template injection, and we will want to include that in our notes. Let's go ahead and take a screenshot of that. We'll go here, we'll get the full page, and we'll put a red box around our payload. I'm going to copy that, jump back over to our notes, and we will say, finding server-side template injection, like so. We'll drop in that screenshot there. We're going to make it a little bit smaller because it doesn't need to be that big. And we will drop this over there, and let's get a screenshot of what the page or the PDF looks like. If we jump over to our PDF, We have the 49 right there. And there we go. We have our concert ticket, attendee 49, so we are vulnerable to server-side template injection. But now when something is vulnerable to server-side template injection, you have to figure out what templating engine, that's hard to say, what templating engine is running on the back end. And there's a few tricks to this. One resource that I recommend that I find helpful is PortSwigger. So we'll do SSTI PortSwigger. We should be able to see this without even logging into PortSwigger. This is going to explain how server-side template injection arises. But here is what we need to do. We need to detect, which we did. So we're at this step right here. Let me zoom in. If it allows me, we just did the detect step. So we detected it's vulnerable to server-side template injection. We need to identify the templating library or engine on the back end. Then we can exploit it to read files, explore, attack. So to detect it, I already showed you how to do this, the 7x7. They're actually doing it right there as a means of detecting it, and hello 49. So we've already done that on ourselves on this lab. Oh yeah, DJ Chateau, good point. Paying attention to server headers can help identify what engine to target. Does that tell us here? Let's find out. I don't know if this helps us in this instance, but you are right. All right, we'll scroll through here. Here's where we're at now, identify. Once we've detected it's possible, we need to identify the templating engine. And I love this little chart right here. Matter of fact, I'm gonna grab this chart for my notes because I think it's so helpful. Let's go ahead and go down here and we'll do an H3 and we'll say identifying the template engine / library, right? We'll drop this image in here. Why the frick it doesn't automatically left align is beyond me. But we have a few different things we can check here. So we know 7x7 works, okay? So then we have this payload right here. If this works, it's gonna be either Twig or Jinja. I don't know if I'm saying that right. Jinja 2. So it's gonna be one of those two payloads. So let's go ahead and try this one and see if it works. We'll go over to our page here, and it is the 7x7 like so. So let's try that and we'll see if that works. And we have the 7x7x7x7x7, which is going to be, it's going to be Twig or Jinja 2 on the back end. And we can go ahead and add that as a note. We'll say inline code block is if you do the backticks in Notion like that. I'll show you how this works. If we do 7x7 like so, close it out, we have a code block right there, equals, all right, our 7x7. Do another code block for that. So engine is Jinja 2 or Twig. What up, DJ BSEC? Good to have you hanging out over in chat. Why does my restream chat keep turning off, guys? There we go. But engine is Jinja 2 or Twig. So then we can do a little more enumeration. If we jump back over to PortSwigger, we can learn more about this. So after detecting that it exists, blah, blah, we can begin to find ways to exploit it. Now, this goes into a little more deeper detail. What I like for exploiting, though, maybe this is actually more helpful than what I normally use, is I enjoy hack tricks. So let's jump over to hack tricks now. I'm sure they all are good, but let me jump over to hack tricks. And we'll go to, well, we have Jinja 2 right there. So let's just start with that and see if any of these payloads work. So we can try a debug statement. If the debug extension is enabled, a debug tag will be available to dump the current context as well as the available filters and test. This is useful to see what's available to use in the template without setting up a debugger. So we can just try it. This will only work once again if debug is enabled, but it's always worth trying. So we will generate ticket, and you can see it failed out with an internal server error. So that is not going to work for us. We have this, dump all config variables with config. In these objects, you can find all the config environment or variables. So let's go ahead and try that one right there. We'll jump over to this and generate ticket. That one worked. And you can see that one also worked. So we have a few pieces of information that is actually quite helpful to us, especially in a real pen test. We do have the config. You can see debug is set to false. If that was set to true, our last payload would have worked, but because it's set to false, it is not going to work. We have a secret key. Now, this is a Python Flask application, and the secret key in Flask is used for, I believe, the sessions, if my memory serves me correct. And we have the secret key, very secret key, believe me, mate, love it. We have our permanent session lifetime, etc., etc. See if there's anything else interesting here for our purposes. I don't think so, but that stuff is pretty interesting. Let's go ahead and add that to our notes. So we can go ahead and jump over to our notes, and we will say, I'm just gonna go like this. No, not like that. Config to config, and we'll do a code block for that. And I'm going to copy all of this because maybe that will come up in the future. So once again, what I want you guys to see in my note-taking process, taking notes is super important, not just when we're working through the lab, but later on when you encounter server-side template injection, you're going to have all of your notes from previous labs that you'll have an idea of how to exploit it, what you ran into in the past, and things that you might be able to dig into. But we were able to do that to dump the Jinja to config. Once again, I'm pretty sure I'm saying that wrong, but we're going to go with it. We can scroll through here. Really, our goal is we want to try to get code execution. And once you go through these, I said before, I've done this lab. And when I did this lab, I just tried each one of these until I got one to work. I will show you the one that works, and I'll walk you through kind of what is going on when it does work. So let me copy this over here, and I'm going to drop it into maybe a notepad might be helpful. So here's a payload that is going to work for us. Make this a little bit bigger for you guys. This template reference context namespace init, which means initialize. We're doing a global variable, and we're going to run an OS command ID, just to see if we can get code execution on the machine. If you would go through hack tricks and fuzz it, you would eventually find this payload and you would be able to get code execution on the machine. So let's go ahead and copy this, and we'll see if it works, which it should. Generate ticket, keep, grab, boom. We are root on the machine via code execution. Roger said, are your notes available publicly? Yes, so when I do these machines, I drop the notes I made during the stream. So if you're watching this after the fact on YouTube, the standalone video, and you don't see my notes in the description of this video, it's because, like usual, I forgot to drop the notes. For those of you watching on stream, at the end of the stream, I will drop a link to my notes. I'll make my Notion notes public for this lab, drop a link to them, and you can add them to your own notes. But speaking of notes, let's go ahead and take a picture, or not picture, just some notes of what we just did. We'll jump over to here, and we will say H2 remote code execution via SSTI, and we'll just say payload. There's our payload, and we will grab a screenshot of the root information. I'm going to grab this, and we'll just go like that. And there they are. We have remote code execution, RCE, via server-side template injection. But what would be more fun is getting a reverse shell. Now, in order to get our reverse shell, we have to remember we have this compromised EC2, which we might need for the reverse shell if we can't hit our IP, but we'll try both of them. Now, when it comes to doing reverse shells, there's a bunch of different ways you can do it. What I like to do when it's something like this, in server-side template injection, because there's so many things that can go wrong in the character encoding, is I like to do what's called a character-safe reverse shell. You can find information about this type of reverse shell on Hacktrick. So if we just do character safe reverse shell Hacktricks, I think it's this page. We'll find out. Oh, is it this one right here? Yes. Well, it's similar to that one. I'll just show you guys how we're going to do it. If we open up our terminal, I'm going to rename this terminal. We'll call this EC2. That's one of the EC2s. And we'll rename this terminal. What we are going to do is we want to create a reverse shell, but a reverse shell that is all base 64 encoded, so there's no unsafe characters or things like commas and quotes that might cause the shell to fail. So let me go ahead. Can I zoom in on the terminal? Here, I'll zoom in for you guys so you can see it better. And here is what we are going to do. We can echo, right? So we just want to echo this to the terminal so we can base 64 encode it. And we're going to do a standard reverse shell, which is bash-c. Hopefully I do my syntax correct here. Like so. Dev TCP. You can get the syntax anywhere online, and we can try first to do RIP to see if we can get a reverse shell back to our machine. If not, we can use the EC2 compromised machine that we were given in the beginning of the lab, and then we want to specify the port. Now, real hackers, of course, use port 1337, so that's what we are going to use. And we will close it out like so. So that is the reverse shell, but now we want to base 64 encode it. So we're going to pipe it over to base 64, which is a utility built into like every single Linux terminal, and go like so. And that gives us this base 64 string. Now what we want to do is add that into our payload. So I'm going to grab the syntax from my notes right here. And I will also drop this to my own notes so you have the syntax there. But that's where we're going to drop it in at. So you can see the command is essentially the same. The only thing we're doing now is we're executing our, hopefully, character safe reverse shell. We're going to base 64 decode it and then run it with bash and throw any errors at dev/null and hope that it works. So we can grab this string right here, jump over to this, and we will drop that right there. Take out the extra space, and we'll just see if this works. We'll do netcat and NVLP 1337 like a real hacker, and we'll go over to this and drop it in like so. Cross our fingers and click generate ticket. And hangs, which is a good sign, but it does not execute for us. Now we can also do it in name here probably as well, but it looks like this is unsuccessful, which is something I wanted to show you, because if at first you don't succeed, think about a different way of doing it. Think about what tools we have at our disposal. I'm going to go ahead and refresh this page. So it doesn't work on our attack machine, but remember, we have a compromised EC2 that might be on the same subnet, might be on the same network, that we might be able to get a reverse shell since we fully compromise this. So if we do like IPA, we can see our IP right here, 10.79.0.2220. So what if we do the same kind of syntax, but we use that other IP? Let's give that a shot. So we'll clear that out. We will grab the IP of our compromised EC2 machine, drop that in, click enter, and now we are given this string. So let's go ahead and copy this string. We can jump over to our notepad, and we just want to replace our previous base 64 encoded character safe reverse shell. And we will copy that. Let's start a listener. Whoops. Okay, Control Shift, there we go. Let's start a listener on here on port 1337. Jump over to this, paste in the string, click generate ticket, cross our fingers, and there we go. We have a reverse shell into a pod, which should make you think of Kubernetes and Kubernetes pods. Let me get a drink of water. Network Chuck's always drinking coffee, but I don't like coffee. So you can buy the Tyler branded Hack Smarter water at hacksmarter.org. I don't really have that, but I should make some Hack Smarter water bottles I can drink on stream for the water breaks. But here we go. We have the shell right here. Let's go ahead and add this information to our notes so we don't forget it. We'll jump over to our notes. We have a remote code execution. And we'll do reverse shell to the compromised EC2 payload. Drop it in like so, and we can grab a screenshot of the terminal, right? We have this. Who am I? We are root, and we will grab a picture. Well, we'll just go like to that part right there. I think will be good enough. We'll make that a little bit smaller because we don't need to be that big. Just proof that we were able to get our reverse shell. So let's go ahead and review our notes up to this point. This is what I love about the table of contents feature in Notion. Now, this video is not sponsored by Notion. Matter of fact, I have the free version of Notion. I don't even have the paid version. So Notion, if you want to give me the paid version for free, I'll take it. But I literally just use the free version of Notion. So everything I'm doing, you can do for free. You don't need a paid sub to Notion. Yo, what's up, Justin Gold? Thank you for stopping in. Good to have you here. But look at our notes. We have our web server enumeration. We have our in-map scan, our web app enumeration. We have our finding of server-side template injection. We identify the template engine and library. We got remote code execution via server-side template injection. And we have a reverse shell to the compromised EC2. And of course, we have our compromised EC2 here, knowing that we had root access. So let's go ahead and do a new header here. And we'll call this post compromise on the web server. Like so. Now, jumping back over to our terminal, one of the first things you want to do when you get on a machine like this, one is ID, but like we don't have to do privilege escalation, at least in the context of this pod, because it is running as the root user, which is actually quite common in Kubernetes infrastructure, even if it's not security best practice. But one thing that might be interesting in Kubernetes and Docker and some of these containerization and containers is to look at the environmental variables. Often secrets, credentials, keys are passed in the environmental variables, so they might be processed on the container. And one easy way to check that in Linux is by typing env for environment. And when we type env, we are given a lot of information. Let's go ahead and just copy all of this information and drop it into our notes, and then we'll look at it a little bit closer. So we'll say checking environmental, I can't say that. Environmental, we'll just say checking the environment. How about that? Code block, like so. So a few pieces of information that should stand out to us. We have a Kubernetes service port on 443 and a sold out master service port on 5000. So that's interesting, something we didn't have access to before. We have the Python version going on. We know that the directory that we're in right now is app. We have our sold out master service host of 10.104.41.166, which I believe is different than everything we have so far. Yep, so that's going to be a different host. Python setup tools version, home root, sold out master service port, Kubernetes port. We have a GPG key. A lot of interesting information that might be helpful to us. When it comes to Kubernetes enumeration, there's a few different things that we can do. One is grabbing what's called a Kubernetes token. So when Kubernetes is set up, we can do a little bit of researching on this together. If we just type in Kubernetes token, maybe Hacktricks, I always just add Hacktricks onto the end of everything because they got some great resources here. So we'll zoom in on this so you can see it. If you've compromised access to a machine, the user may have access to some Kubernetes platform. The token is usually located in a file pointed by the environmental variable kubeconfig inside of kube. In this folder, you might find config files, the tokens, and configurations to connect to the API server. In this folder, you can also find a cache folder with information previously retrieved. Service account tokens, similar. It's an object managed by Kubernetes and used to provide an identity for processes that run in a pod. Every service account has a secret related to it, and the secret contains a bearer token. This is a JSON web token, or JWT, which is often used in any type of cloud stuff as well as web apps for authentication as a bearer token, a method for representing claims securely between two parties. And we're given some information on where this directory might be. So the first one it says it might be is this var run secrets Kubernetes IO service account, and then var run secrets Kubernetes IO service account. So we can go ahead and just check these. If we copy this right here, we'll jump over to our terminal, and we can ls rather, and we do have some information here. So we have a token, so we can go ahead and see what is in that token, and we are given what appears to be a JWT right here. Now, one thing you can do with the JWT is jwt.io will decode the JWT to give us a little more information about it. And you can actually use this on pen tests. I think someone was concerned when I said that before, but everything going on here is all done on the client side. They're not storing it on their servers at all. And this is a legit org. But if we paste that in, we're given a little bit of information about what is going on. So we can see that we have the Kubernetes cluster, Minikube, we have our pod A, we have our service account here, which is what the JWT is for, and we might be able to do some enumeration for that. One thing that we can do is to enumerate any API resources. Now, this is just a lot of Googling ChatGPT to figure out the syntax when I was going through this, so I'll save you the pain. But before we do that, let's update our notes to make sure we are taking good notes on all of this stuff. So we have checking the environment, and we'll just say retrieving the Kubernetes service account JWT. And we'll drop the syntax in there as well as the JWT. So we'll go like so. And we'll turn on word wrap, or wrap code rather. And we'll just space it out so the JWT is able to be seen clearly. And we can even add the information for taking good notes from here on all the information that is in the payload of the JWT. Like so. And now, I've been talking a lot. Hack smarter water break. Now, there's a lot of things you can do with this. One of the best tools that you can use is a tool, I believe is called kubectl. I'm actually looking at my notes to remember. It is kubectl, but you can enumerate some of this manually with curl. So I'm going to show you how we can look at all the available API resources with that JWT using just curl, but then we're going to use kubectl, a really cool machine used for Kubernetes pen testing and Kubernetes authentication. Can I clear? I don't have environment. Okay, that's fine. Here's how we can do it with curl, and it's going to look confusing because it kind of is confusing, but I do want to show you the full syntax here. If we do curl -k -h, now, so far everything should make sense. -h is going to pass it our cookies, or headers, not cookies, but headers rather, and -k is going to ignore any certificate errors, and we want to pass it our JWT. Now, JWTs, or JSON web tokens, are often passed in an authorization bearer header. So we can go ahead and type that, authorization bearer, if I can type, and now we want to grab our JWT right here. Oh no, that we already have the quote. And that is going to serve as our authentication. And now we want to hit the IP that we saw running. If we jump back over to our notes, I believe it's going to be this IP right here. I'll go ahead and give this a shot, see if I'm right. Like so, and APIs. We want to see what APIs might be running on the machine, and let's hit enter. If my syntax is correct, it will work. If my syntax is not correct, it won't work. And it looks like my syntax was correct. So let's add that to our notes as well. We will call this maybe enumerating available API resources. There might be some interesting stuff in here that we can dig into with curl. Add a code block, jump back over to this, and let's just grab this full syntax, and we'll look at it a little bit closer together to see if there's anything interesting in here that we will want to dig into more. And I'm going to shorten this command. We'll just go like, we'll copy all of it right now, jump over to our notes, but we'll put a placeholder here for the JWT. A little bit easier to read. So what are we given? Well, we have an API group list, and we have a few different APIs, API registration. We have apps, we have events, we have authentication, we have authorization, we have auto scaling, we have batch, we have certificates, networking, policy, RBAC authorization, storage, admission, a bunch of different things. Now, you can try to do all of this with curl. And I emphasize the word try because when I was going through this lab, my first time blind, kind of stumbling my way through it, that's what I try to do. I try to do everything with curl, and I got kind of far, but I was like, okay. We're going to use kubectl, we're going to transfer it to the machine, and then it worked a lot better. So now I'm going to show you how to transfer files from our compromised EC2. Well, now we have two compromised EC2s, but are very confusing. Our initially compromised EC2 to our newly compromised EC2. Let me just go ahead and make this straight in our tabs. This is our newly compromised EC2 right here on this tab. And we will scroll down. I'm going to name this one node, right? Now we know what that is. And we will go over to this one, and we will call this one our EC2. That'll keep it a little bit more clear, at least in my own head. And if we jump back over to our notes, we can go to our credentials, and let's log into our compromised EC2 again, because remember, we have a shell on the one port. Grab our password. There we go. Neflo said hardcore doing it with curl. I got somewhat far, dude, just using curl. You would not believe how frustrating it was, though, trying to get the syntax correct when I'm trying to freaking enumerate the Kubernetes API with curl. I don't recommend it. It's overly difficult, and there's no reason to do it that way. But we have tools here on our compromised EC2, which should be the hint to us, hey, maybe we should do something with this, right? So we have ls, and we have tools right here. Lagolo NG, which we can use for setting up port forwarding and such. And we have nmap, but it doesn't have kubectl. So let's go ahead and see if we can get kubectl, which I don't think I have on this attack machine. Oh, we have bash completion. Do I have kubectl? No. Let's go ahead and get the binary for kubectl. So in order to get the kubectl binary, it took me just a second with some help from the stream because I couldn't remember how I did it. We'll go to Kubernetes.io, docs, task, tools, install, blah, blah, blah. You'll see this in my notes, but we are given the syntax right here to go ahead and get the binary. So let's go ahead and download this here. We'll jump over to our terminal, clear all my silly troubleshooting stuff before, and we will paste in that command. And I need to zoom out a little bit. Well, if it's going to let me. It's not letting me zoom out. That's definitely what I was clicking, but I'll do it manually if I need to. One more time. Zoom out. And we have kubectl. You can actually see it right there, although it's not executable yet. But we can cp kubectl. I'm just going to put it out one directory. TL. Why can I not copy that? Cannot overwrite kubectl. What? Oh, it's trying to use the folder. No. What? Yeah, it was like trying to do the folder since they had the same name. That was the confusion there, but you know, I figured it out. And now we have our cube. Oh no. We already had the folder. There's my kubectl. Okay, here we go. Guys, struggle bus in here. Here's what we're gonna do. We're gonna just remove that folder, and then we're gonna move our kubectl binary to kubectl, and now it works. All right, struggle busing a little bit there with the folder and the binary having the same name, but now we have it here. Now what we can do, we can transfer this file in a few different ways. I don't remember does this have wget? It does. Okay, cool. And our terminal here has this. So we have wget here and our terminal. We can do Python 3 web server. We'll host it on port 80 on our attack machine. And then on our initially compromised EC2, so not the node, because I don't think we can grab it directly from here. We can try it. So if we just go over to temp like so, we can do like wget 10.8.0.137 kubectl, but it's not, well, it doesn't even have wget on it. But here we can do HTTP 10.8.0.137 kubectl like so. I think. If not, we can use SCP to transfer it. And I think that's what we're gonna have to do because of the networking things in place. Port? It is, no, it's the right port. So instead of using the web server, which I think is the networking restrictions that are stopping us from being able to do that, we can use SCP. But if you're like me, I always forget the syntax for SCP. So let me just go ahead and figure out the SCP syntax. It's super easy, and I don't know why I always forget the SCP syntax, but here it is, SCP file name, and then we want to put it on the remote directory. So we can just go ahead and copy the syntax, jump over to this, and we will transfer the file. So we'll want to do SCP. Is that even on the machine? Yeah, okay. Say it should be. kubectl. We'll say administrator, if I can type, administrator at our remote host, which is going to be our compromised EC2. And we'll just drop it over in a temp. Oh, good call, Hack. Make sure to compress the kubectl binary to save some transfer time. I think we have to do, well, like so. There we go. So now we have it compressed. We can make sure it works. I think it worked. So I'll make sure it works before I transfer it to the box. There we go. It does work. All right, so we have this compressed archive just to speed up the transfer time. And now with that, now we can go ahead and do our SCP command. So it's SCP. We want to give it the remote file like so. And then we want to go ahead and give it the host that we're logging into. So we're going to do administrator at that. And then I believe it is the directory, and I'm right. And we'll just transfer it over to temp like so. And we'll give that a shot. It's going to prompt us for our password. Let's grab our password from here, and then we're going to take a pause and make sure all of our notes are filled up with this information. And that's perfect. While it transfers this, we'll go ahead and add all of this information to our notes. Everything that, well, it went fast. Everything we did up to this point. So if we drop over to our notes, we will scroll all the way to the bottom, and we'll call, let's see, we'll say transferring kubectl to the node. Step 1, compress. Well, first, I guess let's download kubectl. And we'll grab the syntax for that. Have it there. And now that's downloaded, we can compress it to speed up the transfer. And we'll grab our syntax that we used right. If I can go back, there we go. Grab the syntax for that. Use SEP to transfer to the compromised EC2. Like so. All right, there we go. Apparently SCP is appreciated now. Oh, well that sucks. Still works for me. YOLO. So we have transferred it to the EC2, but now we need to transfer it to the node machine so we can play around with it. So let's go over to our EC2. We'll CD over to temp, and hopefully we have it here, and we do. We have the kubectl gz package right there, and we have this right here. We're in the temp directory here. We're in our temp directory here. I mean, there's probably a few different ways that you can transfer this file. I'll show the way that I generally transfer a file this way. First, we can host a Python simple web server on our compromised EC2. We'll do python 3-m HTTP server, and we'll do 8080. I think that port is open, and it is beautiful. And then on our node, we're gonna go ahead and do, we can use curl to transfer it. So we'll do curl, our output file we'll call kubectl.gz. And now we wanna go ahead and get it from this originally compromised EC2, which I don't remember the IP. Here it is. Like so, and port 8080. kubectl.gz. I think my syntax is correct there. We cross our fingers and we hope it works. And it did. So we have it there. And now tar xf kubectl.gz. ls change mod plus x. And we successfully got kubectl on the node. Now, as usual, let's make sure we update our notes for everything that we did. So we'll say the first step was hosting this on the compromised EC2. So we'll jump over to our notes. On the EC2, host a simple Python web server. We'll drop that in there. And then on the node, use curl to download the file. Decompress it and make executable. And we'll just include all that in one step. So we downloaded our file right up there. So we'll start right there, and we'll just scroll down right to there. I think that'll be good enough to show all the steps. And now, ladies and gentlemen, the Hack Smarter water break. Can the compromised AWS instance not reach the Kube API? I don't believe so. We can check, but I don't think it can. But let's go ahead and check real quick, and let's test that assumption. I might be wrong. I think this is the port that we want to hit. And yeah, I don't think it can. Actually, I need to ignore any certificate errors. And it just times out. And yeah, we'll get to Legolo NG eventually. But now let's go ahead and do some Kubernetes enumeration. The first thing you want to do with enumeration is checking what permissions we have. So the way we can do that is we will run the kubectl auth can I, like, hey, can I do anything? And we'll say list. What can I do with my current permissions? And we are given some information here. We'll just go ahead and copy this to our notes for our syntax. And we'll go to our notes. Enumerating permissions with kubectl. There we go. Oh, port 6443 or something like that. And yeah, so Hack said generally K8s APIs are not exposed publicly. So that's why the EC2 can't hit it. But if we look over at this, we can see some things that we might be able to do. So we have self-subject reviews, create. We have secrets, which should stand out to us that we can get and list secrets from what I can see there. And so if we want to retrieve secrets, which seems like a good thing to do, like if we can get secrets, let's go ahead and test if we can get secrets. Let's give that a shot. Over on our node, we can do that with kubectl again. Super easy syntax for this. Get secrets. Don't try to do this with curl, it sucks. And we have a secret right there. So we have our my secret. And we can go ahead and try to get that information by getting the secret. So we'll do that with kubectl, get secret, of course, my secret, and we'll say output of YAML. And now we have a secret. Let's go ahead and copy this, and then we'll figure out what is going on. Jump back over to our notes, and we will say enumerating secrets with kubectl. Like so. Oh, Jay Chen just said, I just got the email from OffSec saying I passed the OSCP. Exam was Monday. Sunday night I watched your video about the report writing part. Dude, congratulations. Amazing. And thank you for dropping in chat to letting us know. That's amazing, dude. Awesome, awesome job. If we look over at our Kubernetes stuff, we were able to get our secret. And we have one secret right here called my secret. And then if we want to get the secret of my secret, we can pass it to the output of YAML. And we have a password and a username. Now it's very clearly, if you've ever done any CTFs in general, this is base 64 encoded. As soon as you do enough of these, you begin to recognize very quickly when something's base 64 encoded. Usually these type of letters, lowercase, uppercase, and this is especially a big idea that this might be base 64 encoded. And we can go ahead and base 64 decode it really easily in our terminal. So we'll go ahead and grab the password, for example. We'll go over to our terminal right here. We'll exit out of this stuff. And if we echo, we just want to pass it that. We'll pipe it over to base 64 and then -D for decode. And that gives us this as a password. So let's go ahead and grab this. And we'll drop it over here. This provides a username and password that are base 64 decoded. We can decode with echo string base 64-D and put it in a code block. And then we'll just drop the code block down here. We'll say password of that. And username. All right, here we'll do the same thing with the username. Copy that, jump over to our terminal, echo base 64-D and a username of admin. So we have an admin username and an admin password, but we're not sure what that is for yet. The next thing that we can do, and when I was doing this live, this is where I got stuck for a long time. I tried using this admin username to SSH and tried using it in different places, and I was unsuccessful. And the part that I missed was doing an internal port scan on our node machine. So if we jump over to our node, and we do, I guess, ifconfig apparently. We have this IP right here. This is on a different net. Okay. Not ipconfig, IPA. What are you, it's not Windows, Tyler. What are you doing with your life? But if we look over at our tools, was it here? Where was my tools at? There they are. We have our tools. We have InMap here that they put on it for us, which is very nice of them, right? We could just make sure it works. Okay, not permitted. Yeah, right. I am root. You'll shut your mouth. I will decide what is permitted, not you. Jump back over to our credentials, grab our password. And that works. Beautiful. So we can do the same thing we did before. We can host a simple Python web server on port 80, go over to our node. We're already in the temp directory, and we can do curl-o InMap, and then we can grab the IP that we are using before. So we'll grab the IP there, like so, and InMap. Okay, and now let's add that to our notes. I'm not going to add all the full details because we've already shown how to do a lot of that already. So we'll jump down to here. What are my notes so far? Post-compromise. You know what I want to do? We'll fix our notes later. We'll call this port scanning with Nmap. All right, first you need to transfer Nmap the same way we transferred kubectl from the EC2 to the node. Okay, that's all I'm doing for that. They can look back at the notes and figure out exactly what was going on. But let's go ahead and get Nmap. We have it on the machine. We have made it executable. And now we just want to see, hey, what hosts might be open on the web server? Very quick way to do a network map, really a ping sweep to see what's alive, is with this syntax. We'll go ahead and do Nmap like so, -sn. We want to see what might be up for us, and we'll just drop in something like this, and we'll do T5 to make it faster. Now, the reason I'm doing that is just because of our current IP right there. That should get anything that might be up, and we will do enter. And we went ahead and did it. We have a few hosts that are up, it would appear. We have Nmap scan for 1, 51, and 52. So we have 3 hosts that are up. Let's go ahead and add this to our notes, and we'll also add each one of those hosts to our notes so we can further enumerate them. We'll say hosts that are alive. We'll drop the syntax in there, and then we'll just do another code block, and we'll just drop each one of those hosts on their own. This is probably the gateway, probably not super interesting for us, but we'll drop it in there. We have the 51, and we have 52. Yeah, Kubernetes UR is very confusing. Like, I'm still very much a noob at Kubernetes, and this is the second time I've gone through this lab. And the reason I wanted to go through the lab twice was just because it was a struggle for me the first time I went through it. And now the second time, things are beginning to make a little more sense. And also the lab is complex, guys. Like, we've done so many things so far, from web app, server-side template injection, transferring files, and we're still not done. Now we're doing an internal freaking network scan, all as part of one lab. And now what we're going to do is we are going to set up pivoting with Legolo NG, which is going to be a lot of fun. And then we can see kind of what is going on with these servers here. So let's go ahead and set up pivoting, and then we'll dig into some of these hosts and see what we might be able to do with them. So let's start a new H2, or maybe H1, setting up pivoting with Legolo NG. Now, if you don't know what Legolo NG is, you should check it out, especially if you want to learn pivoting. It is by far the best tool that I have found for pivoting. I remember when I was studying for the OSCP and I learned like a bunch of different pivoting techniques. I didn't know about Legolo. So I used to use Chisel back in the day. Chisel is also an incredible tool, but it's not quite as cool as Negolo. So it's tunneling like a VPN, an advanced yet simple tunneling tool that uses ton interfaces. So very cool tool, and you can watch the walkthrough all this stuff yourself. I'm going to show you step by step how we can set up tunneling. So we'll go over to our machine and also document all of this in our notes for after the fact, so you can access my notes if you find the tunneling part confusing. But this is going to be helpful for those of you studying for things like the OSCP or the CPTS that's going to require any type of tunneling. We already have it here. We have an agent and we have a proxy. So there's a few things that we need to do on our victim machine, which is this EC2, and some things we need to do on the node. But the first thing that we want to do is transfer our agent binary right here over to the node, and we'll do that in the same syntax we've been doing. So I'm going to do a Python web server on port 80. We'll go over to our node and we will do curl-o, whatever our IP is, right here, and agent, and I also need to specify the file there, agent, like so. Agent. And we have it there. We'll make it executable. So we have that on that machine. Now what we need to do on our attack machine, or in this instance, the EC2 that we have running right here, is let's go ahead and set it up. Once again, I will include all of these commands in my notes that I'll attach to this video, but here's what we're going to do if we're going to follow along. First, we're going to do this IP, set up our adapter. We're going to add our user root, because that's who we're signed in as right now. Mode ton Legolo, right? Just memorize that. Don't memorize it. Just include it in your notes. IP link set Legolo up. We want to turn it on. And now we can go ahead and look at our proxy, and we're going to do proxy self-cert. Now that's not recommended if you're doing an actual pen test, doing a self-certification, but for this, self-cert works just fine for our purposes. And we'll do it like so. Fingers crossed. And now we jumped into Legolo. And now we need to create an interface. So we'll do interface create, name, and we can call it Evil Cha. I think that's what the lab guide uses or the GitHub uses. We'll just go with it like so. So those are the commands we need to run on our attack EC2. Once again, I'll put these into our notes. If we look over at our node right here, we just have to run one command so far. We have our agent right here. So I'm going to do agent to connect back to our proxy that we just set up. We're going to pass it the connect flag. And now we need to go ahead and grab the IP right here. Not open link. Tyler, what are you doing with your life, dude? More copy selection, rather. There we go. And then Legolo runs by default, I believe, on port 11601, and ignore cert because we're doing the self-signed cert. Otherwise, it won't work, saying it is not secure. My phone's still telling me to stream on Twitch. My phone, I am streaming on Twitch, my friend. Or do I have a text message to make sure it's not my wife? All right. Ignore cert, and we should be good. And I'm going to go ahead and hit enter. And let's, fingers crossed, we will see what happens. And so far, so good. It seems as if it connected back. If we jump back over to this, it says that an agent joined. Now, back on here, what we can do is we'll do tunnel start. Actually, no, session first, I believe. Session. We have our session right here, root at pod A. I'm going to go ahead and click enter to select that session. And then we will do tunnel start ton evil cha, like so. And then finally, interface, add route. So we want to add the route so we can hit these other servers. Name, evil cha, route 10.244.0.0, and then 16 for the subnet mask. Fingers crossed that I'm doing this correctly. All right. Route created. And then finally, what we need to do is we need to set up an SSH tunnel so then we can hit stuff from our attack machine. So let me just, I don't have a good way to diagram this. Let me pull this up right here. Here is what we have going on. We have my Kali box, and we have our EC2, and we have the node. And here's kind of how things are being set up. Our node is connecting back to our EC2, which is going to connect back to our Kali machine. So then with our Kali machine, we can connect to the node. All right. Confusing. But that's a little bit about what is going on. This is right here is going to be what we're setting up. This is our Ligolo NG tunnel. And now what we're going to do is set up a dynamic SSH tunnel to connect back to the Kali, right? So this connection right here, we'll just say Ligolo NG. And this right here, we will say dynamic SSH. Very confusing. I bet there's probably a way to do this with Ligolo alone. Maybe. There probably is, but I don't know how to do it. But I know how to do it this way. So this is the way that we're going to do it. If you guys want to let me know in the comments how you can do this with just Ligolo, I would be interested in trying that out as well at a future time. But here we go. Node connected to EC2 with Ligolo NG. And now we're going to connect our EC2 to our Kali machine with dynamic SSH. And that is easier than it sounds. All we have to do is do SSH/D. We can specify 9050. And then our administrator IP, or our administrator credentials. Let's grab the IP right there. And we'll drop it in. Just going to prompt for the password. And we'll grab the password. All right. Now that we have that, we'll just call this like SSH port forward. We can open up a new tab right here. And now we could try something like, if we go back over to our notes, we have these other hosts that are alive. We could try to, like, for example, hit this host with something like proxy chains -Q for quiet, nmap T5-V. And look, it works. We right now are doing what I just showed you. We have all of these things set up, and before we go any further, let's add this to our notes. I'm going to cheat a little bit from when I did my own notes the first time. I'm just going to copy them from my notes so you don't have to watch me do all of this. Let me just copy. Oh, maybe it's not going to let me copy very well from Notion for some reason. Let me try this one more time. All right, jump over to this. Let's see if this works. Okay, it does. Beautiful. Pod, set up dynamic SSH tunnel. That was relatively easy to do. And that was just with that SSH command. Like so, right? So we set up pivoting with Ligolo NG, and then we can go ahead and say like verify the connection with nmap. And that's exactly what I did. We'll just drop in a code block there and just show how I did that with nmap. Do I have a terminal? There it is, right? Showing proxy chains and that full syntax there. Wow, so proxy chains, we have that there. And we do see something interesting on here. We have port 53, 8080, and 8181. Now, 8080 is often a web server, so that might be worth checking out ourselves. And we can do that right here in Firefox. So what I'm going to do is we'll close out some of these extra tabs. We can go to Foxy Proxy, and we can go ahead and set up a new proxy, okay? I believe that you're going to work. We'll do, maybe, is it options? Do I have to do first? Okay. Options and proxies and add. And we'll just call this Kubernetes. For our host here, it's 127.0.0.1. Our port is 9050 because that's what we did for the dynamic SSH port forwarding. And I think that's everything that we need for the proxy. We will go ahead and save it. Proxies, Kubernetes. The one adjustment that we need to make that I forgot to make is the type. You can see right now the type is HTTP, which we do not want to do. Our type we want to do is SOCKS 4, and that's what we have set up with on port 9050 is the SOCKS 4 connection. Let's go ahead and do save on that, and let's see if that fixes the issue that we're running into. All right, we'll close that, and let's give this another shot. And now we get page not found. Can I do anything with it? Nope, nothing on it. What was the other host? Is it like 52? Does 52 have anything running on it? Oh, let's try that real quick. We'll do curl, proxy chains, curl, HTTP. Let's do 52. And that also times out. Let me think for a second about what we might be doing wrong here. Maybe we're looking at 52. We're looking at 51. We haven't looked at, let's see, did we scan 51? We did scan 51. What's open on port 52? I think that was our other port. Let's try that. Proxy chains, nmap, and we will say 10.244.0.52, right? Because we scanned 51. What did I scan up here? Now I'm confusing myself. Yeah, we scanned 51, T5-V for verbose mode. And my friends, that is why you do -Q mode for quiet. And then you don't see all that stuff. While that does its thing, let's see if anything pops up. That shows our proxy chains shooting through there. And that doesn't seem to want to do anything. Oh, we have an open port on 5000. Let's go and check that out real quick. Maybe that's a web server for us. Otherwise, we can enumerate that port a little bit more. Fingers crossed. I notice I have to stop it to get it to load. I think that's just while it's going through proxy chains. But we do have a login here with a username and a password. Now, before we continue, let's go ahead and get caught up on our notes. So we verified the connection, and we will just say enumerating hosts. The most interesting host 10.24.0.52 due to a web server running on port 5000. And let's go and grab our nmap command here. Right, we have it right there. We'll copy. And then we'll also grab a screenshot of the login screen here. If it loads. You guys saw me paste a screenshot in there, but apparently it's not going to load. Okay. That's fine. I didn't want to actually have the screenshot in there anyways. Whoops, wrong thing. Wrong thing. Try that one more time. All right, copy. Notion, don't film me now. My gosh, what? Wow, okay, whatever. There is a login screen, but Notion is dumb and won't accept my screenshot. But now, if we look back at our notes right here, we have covered so many things. If we go back to our enumerating secrets with nmap, remember we have this admin and password. And if we look over at Firefox here, we have a username and a password. So we might think, maybe those things go together. So let's go ahead and copy the password here. Go here, type in admin, password, login, don't save. And like I said before, I noticed, I think it's through all the crazy proxy things going through, but it seems to pause endlessly here. If you just stop loading it will go to the next page, right? I don't know why it is that way, but it does eventually go to the next page, and we were able to authenticate. I don't understand why I couldn't take screenshots. Let me try it from my host computer. We'll see if this works for my host computer. I'll go like this, and we will go ahead and copy the screenshot, like hardcore copy it. What the heck? I don't know why it's not allowing me to take screenshots. Can I take screenshots from my other page? You guys see that? What? Is there a screenshot limit in Notion? That's odd. Well, I guess I can't take screenshots of this. For those of you watching the standalone video, you're just going to have to believe me, right? We'll just say, why can't I? Notion is bugged, y'all. Oh, something's not right retrying. Oh, guys, we're dumb. Guys, we set up the proxy in Firefox. There's no way for Notion to connect because it's being routed through our SOCKS proxy to the other internal network. Oh my goodness. All right, we're just going to we'll keep running with this and we'll go back and take notes, but that's hilarious. That's the downside of using a web-based version for taking notes in the same freaking browser you're doing your hacking in. But we see some things here. We have a home, a dashboard, a ping tool, and a logout. Now, if you've ever done CTFs, one of the most common things you'll discover is remote code execution in a ping tool. So if we click the ping tool here, something that happens often is this is just running a raw command, whatever the user input. So if we do 127.0.0.1 and we can go ahead and ping, exit out, you can see it's trying to run command. So if we just do like who am I, we're going to close out the command with that semicolon. Let me see if I can just zoom in for you guys. Close out the command there, try to escape the command, and then run who am I. We'll hit ping, and we'll just close it out. And you can see we have command execution with that syntax right there of the who am I, ping, close out. And now we can go ahead and try to get another reverse shell, but our character safe reverse shell. So let's go ahead and try that. We already recorded in our notes that are now broken, but hey, at least we're on this machine. And if we go over to our remote code execution notes, we have it right. Compromise EC2, reverse shell to compromise the EC2. Did I include? Oh, did I not include the commands to actually run it? I must not have. So I probably should have included those commands, but that is fine. We'll go ahead and just do it again together. We'll open up our terminal, and I'm going to copy it from my other notes, and I'll add it eventually to our OneNotes. But we're going to do the same thing we did before. We're just going to echo in our command. Nope, that's the wrong syntax, Tyler. Let me grab this, clear, echo in our command, and 444 will be fine. I don't think we've used that port yet. And we're going to give it our node, I think. I'm trying to think of how we'll do this. I think we will get the reverse shell from pod B onto pod A. Because of the way networking is set up, we'd have to do that, right? I think so. So let me just think about this for a moment. We have our EC2 right here. We have our SSH port forwarding right here. I think I actually need to set up another EC2 terminal, and we'll SSH as administrator. No, we don't need to do that. Yeah, we do. SSH as administrator. This is very confusing in my head as I'm trying to figure out all the different networking that is going on here. But if we SSH in as administrator, we're going to jump up to our credentials here. We're We're going to grab our IP here. We're going to jump over to here, drop in the IP, grab our password. All right. And now that we have our password, we're going to set up a netcat listener, and we'll just say on port 444, which should be fine. And now if we go back over to our terminal here, we want to set up another reverse shell so we can catch another shell from freaking node A. My goodness, my brain, guys, is breaking on this as I try to think through it. But we need to catch a reverse shell again. So we have a second shell as node A, and then on node A, we're going to catch a reverse shell from this other RCE that we had. My goodness, mind blown. This is complex. Do I draw a network topology during work? I don't usually, but I'll be honest. This is more complex than 99.9% of pen tests I do. Like usually I'm not jumping from networks and everything. Like this is some legit having to think through my head how I'm going to do this. But we have this. Let's go ahead and create our reverse shell with our compromised EC2, like so. We'll copy this, and we have our listener there. We'll jump over to K8s because I think, oh, I don't have it saved. Come on, Tyler. We'll go to here. We'll go to generate ticket. What do you mean that's not allowed? Oh, browse concerts, view details, buy tickets, pay. All right, there we go. And if we jump back to our notes that we were using before, we do have the remote code execution syntax right here. So we'll copy that over to here. We'll open up our terminal. We'll copy the new base64 encoded string. We will replace the old base64 encoded string with our new one to hopefully catch another shell. We will generate the ticket and it will break. And that sucks. And that sucks. What did I do wrong here? Let's just make sure everything works. Whoops. Can I do anything here? Okay, I can do something. Can I do config? Just do some quick troubleshooting. All right, I can do config. Let's go ahead and jump back over to our notes. Did I miss something on my notes right here? Global echo. Yeah, we need to draw. Maybe I'll draw this out at the end to help us think through this because this is very confusing. What did I do wrong with my syntax here? If I jump over to this, grab my notes. All right, that's correct, I think. I think I had the notes up here, right, when I did this. Here's the exact command I copied. Okay, I'm going to try to do it here. If we replace this, it's the same syntax. I didn't do 444 the first time, though. Oh well, let's run with it. There we go. We have a shell. So we have a shell now on pod A. Now if we set up a netcat listener, we'll just say 445. We can't set up a netcat listener on 445 because we don't have netcat. So maybe we can just use our EC2 instance. I think I'm making it more complicated than it needs to be. Let's go ahead and grab this command right here. Same command that we were using. We'll go over to our ping tool and we'll just close out the syntax. Literally same command I just used, but instead we're going to try to do it directly from pod B. Because I guess if EC2 can connect to pod A, it can probably connect to pod B. Let's just find out. Ping. Oh, boom. And we're able to successfully do it. There we go. So we have a shell on pod B. Now we're gonna go. We need to guys. We need to document this. Like we need to draw this out so we understand better what is going on. Let's go to Foxy Proxy and turn this off because that shouldn't break anything now that I have the shell. right? And now if we go over to our notes, there we go. So let's go ahead and just refresh this. Let's see if it works. No, how about refresh? All right, there we go. So we set up pivoting, we're enumerating our hosts, and we can include like, I'm not gonna include the login screen. We'll just say there is a login screen and command injection. And command injection as ping. You can escape it with what is going on. Okay, this is the only downside of Notion is the web-based version of it. I'm not going to include all the syntax for that. Y'all can watch the video and figure it out, but let's go ahead. What tools do you guys recommend for drawing diagrams? I've heard good. Okay, so I know this network is super confusing. So as we've been working our way through things, I want to make a network diagram that explains a little bit of the pivoting and the things that we are doing as we set up the second reverse shell into node B. We are going to use exploitation draw after trying a few different things, and I'm going to close this one out, and we will try to demonstrate this a little bit. So let's just begin with the machine that we're on right now. So I'm gonna grab a rectangle here, and we'll just say this is our Kali machine, like so. There's Kali, looks good. I can zoom in a little bit for you all, but there's Kali. That is us on our machine. Now remember, in the beginning of the lab, we had a web server and our compromised EC2 that we already had access to. So let's go ahead and make our compromised EC2. So we'll just go here and we'll just say compromised EC, whoops. Can I make this a little bit longer? All right, we'll just call this the EC2. All right, everybody knows what that is, but we have our EC2 right here, and our Kali has a connection over to the EC2. We could at least SSH into it, and so we have that connection. But then on the EC2, remember we got that first initial shell on node A in the Kubernetes cluster. So let's go ahead and make that. We'll make another box right here, and we'll just call this node A, right? We have our node A here. Let me put that more in the center, but we have node A, and node A is able to connect to EC2, or EC2 is able to connect to node A. So we can go ahead and set that up there. We have a direct connection right there. But then we just discovered as we were doing this, pod B. I don't know why I keep calling them nodes. They're called pods. We're going to go with node because that's what I've been calling it this entire time. We have node A, and now we just got a shell on another machine called node B. Let's jump back over to Excalibur Draw, and we will add that one right here. Node B. And node A has a connection to node B. So our initial issue was, how do we get from our EC2, or really from our Kali machine, how can we hit this internal network right here, this internal secret network that node B is hanging out on? And remember what we did is we set up Ligolo NG to do some of that pivoting and forwarding between the EC2 and node A, so that the EC2 could then hit node A and the EC2 could then hit node B. So let's go ahead and do that. If I grab my color, we'll change this. Let's just give it a blue color. Oh, a node and pod are two different terms in K8s. A pod is the smallest unit in K8s, and node can be a group of pods. All right, deal. Let me change my terminology then. We'll just call this pod A, and we'll just make it accurate, right? And pod B. There we go. But we still have this like hidden network. How do we get to this hidden network from our Kali machine? Because there's no direct connection. So let's make a line, and we'll make it green for the port forwarding type craziness. So the first thing that we did is we set up Ligolo NG, right? So we'll do a green line right here, and we'll just say Ligolo, which we need to make that text a lot smaller. We'll go like that, right? So we have a Ligolo connection to pod A. And because of that, we also have that same Ligolo connection right here to pod B. And because of that Ligolo connection, we have it right here as well. So that solves the one issue with our EC2 can now hit pod B and kind of hit this secret hidden network right here. But we still have this unsolved mystery here. How can Kali hit all of this? Well, we have this kind of internal network that we set up right here with Legolo. So then we invited Kali to the network with what's called SSH dynamic port forwarding, which I showed you. And we set up that dynamic port forwarding. So let's add that one, and we'll just do maybe red for that connection right here. So we'll say from here, we set up SSH forwarding. And we might have to make that smaller. That still doesn't show my arrow very good. So let's delete that and add a different arrow. And we'll just make it, we'll just call it SSH. You guys know what it is. You're watching the stream. I'm going to call it SSHP, right? SSH port forwarding to EC2. But because of that, we can now also hit pod B, because we're able to hit this kind of internal network via the SOCKS4 proxy. So let's do that, SSHP, and we'll just call it SOCKS4 proxy. Well, that's going to make it confusing if we add the SOCKS4 detail. But now we have the SSH proxy set up, which gives our Kali machine access to this internal hidden network. So hopefully that helps us wrap our mind a little bit around. I know that I kind of suck at diagrams, but this at least gives us a little bit of information about what is going on here with this internal network. And let's go ahead and grab a screenshot of this for our notes. And we'll jump back over to our notes, wherever those are at. Those were apparently right here. And we'll just call this Tyler's terrible network diagram. There's my terrible network diagram showing exactly how this network is working and why we were able to catch a shell on from pod B on our EC2, which is what we have going on right here. So now that we're on pod B, we also need to put kubectl on it because I don't think it's going to have any tools here. Let's go over to cd temp and we'll go to the temp directory, and let's go ahead and get kubectl on here as well. So once again, we're going to SSH as administrator at our compromised EC2. So we'll jump up here to our credentials and we will grab our compromised EC2 credentials right here. Jump back over to this, paste it in. It's going to ask for our password. So let's go ahead and grab the password right there. Tools, actually, I think I put it in temp. We have our kubectl.gz, so Python 3, web server on port 80, which, okay, permission denied, that's fine. We'll do it on port 8080. And we will go over to this. We'll name this one not node B, right? Because that's not the correct terminology, but rather pod B to use the correct terminology so it matches our network diagram. So we have pod B right here. And now we can go ahead and grab kubectl with curl-o kubectl.gz from our compromised EC2 on port 8080, kubectl.gz, fingers crossed that it works. And it does, and now we are going to get a drink of water. Let's go ahead and make that executable. Let's go ahead and first unpack it before it makes it executable. That would be a good starting point. And now we can make it executable. And now let's just make sure it works by passing -h for help. And it does. So let's go ahead and document what we have done so far. If we jump back over to our notes, we can go over to here, transferring kubectl, setting up pivoting, enumerating hosts, Tyler's terrible network diagram. And we'll just say pwning pod B. We transferred kubectl using the same process as before from the EC2 to pod B. And now we can do the same commands before as well. So if you remember the command for enumerating what permissions we might have in this container, and with these credentials in this pod B, we can do kubectl auth can I, as in like, can I do anything, and list our permissions. And when we list our permissions, there's a few things that are big. One is this wildcard right here. That says we can perform all actions on all resources. So that is a big deal. We'll go ahead and just copy this and we'll add that information to our notes. We'll say enumerating permissions. What's this? Is this? Okay, heading 2, heading 3. Okay, perfect. We'll drop that in there and we'll say note the wildcard means we can basically do whatever we want to all resources. We are the king. That is who we are. So now what we need to do is we need to escape the pod. And there's a few different ways that we can do that, but ultimately our goal is not just to pwn these pods. We want to escape the pods to get to the actual host, and then maybe, just maybe, we will finally complete this very complex scenario and be able to get the flag. Now, the first thing that we need to do is figure out what images might be on the machine that we can use, because remember, this machine doesn't have an internet connection. So we can't just say, hey, pull this image from Docker so we can escape this container. We need to figure out, hey, what images have already been used? And the way we can do that is, once again, with kubectl. I'll show you the syntax. We'll do kubectl get pods-o, and now we want to pass it this JSON path to see, hey, what items might be in here that have been used. So we'll do items, do the, oh, not that syntax. There we go, like so. All the items and all the images that might be attached to these items. We just want to see what images have been used for other containers so we know what images we might be able to use. We'll go ahead and just clear it up a little bit by transforming it, removing spaces, all that, those good things. I think my syntax is right so far. Remove any new lines. And then we want to sort it so we get it unique. I think my syntax is correct. Unable to match a printer suitable for the output format JSON path. Oh, I see what I did wrong. I'm actually going to copy it out though, because if I do it here, it's going to freak out. We'll copy over to my handy dandy notepad here. The only thing I missed, I think, was an equal sign. Whoops. And so don't do that. I think I broke it. Can I close this out? There we go. All right, just don't do what I just did. I don't know why that didn't work. Let me try it directly from my own personal notes. Does this work? There. Okay, so I did have some syntax wrong there. What did I do wrong? I'm guessing I did something wrong here. Anyways, what it was supposed to do is show me, hey, what images have been used, and we can see two images. We have this internal sold out master CTF and this sold out master concert app CTF, right? So we can go ahead and just grab this for our notes, and we'll just add this so that when I do it in the future, I don't type the syntax wrong. And we will call this finding other images used in containers. Right, we have that. So we have those two images. Now what we need to do is create a malicious YAML file to escape the pod. Now, you could do Googling on this, right? Escape pod with malicious YAML. I think I was looking at Docker escapes and Kubernetes escapes, and this is where I found this article on pod breakout. So you can dig into this if you want on your own to do a little more digging into what you're able to do. But as you scroll through here, we should see some YAML information right here. So example of pod configuration to create a privileged pod in a kube system taken from here. And they give the syntax, but I basically copied this almost identical, but there was a switch that I missed that I was stuck here when I was going through this blind for quite a long time, because I was like, I'm doing everything right. Why the frick is it not working? And I will save you the pain of what I did wrong. So what I'm going to do is we'll go over on this EC2 that we have, just because it'll be easier to edit it on here. And we will set up a YAML file, and I'll show you the exact file that I used, taking it from literally copy and pasting it, but making a little bit different so it matches the images that we saw before. So we'll do YAML, or not YANO, nano rather, and we'll just call this hacksmarter.yaml. And here is the file I use. So once again, very similar to what we just saw. We have an API version of V1. The kind is a pod. We're going to call it HackSmarter 2. You can see it's HackSmarter 2 because HackSmarter 1 didn't work. We can go ahead and just fix that for this one. We'll just make it HackSmarter, container HackSmarter. And this is where I was stuck for a while. I was trying to use other images, but because it doesn't have an internet connection, you can't pull down the images. So you have to enumerate and see, hey, what images are on the app? And that's exactly what we did. If we look back at our notes, we can see that right here. We have these two images, hack10101, sol.masterconcert and internal sol.masterctf. So I just grabbed that one and plugged it in as our image to the latest one. Here was what I missed, y'all. This is what almost drove me to insanity, thinking the lab was broken. But like 99% of the time I think the lab is broken, it's my brain that is broken. Image pull policy if not present. If you do not set this, it will hang because it will try to pull the image out from the internet. It doesn't have a connection to the internet, and so it doesn't work. So you need to set this flag in your YAML file if not present. I learned that the hard way, and we want to mount it on host and see if we can escape the container. So this is our malicious YAML. I'm going to go ahead and save that, and we have our HackSmarter YAML right there. And we'll do Python 3, set up our web server again on port 8080, go over to pod B, and we will do curl-o hacksmarter.yaml p from our EC2. You think I would have that memorized by now, but I don't. hacksmarter.yaml. All right, make sure it all looks good. It all transferred over well, and it did. And now that we have our malicious YAML file, we can create a pod with host access. So we have pod A, we have pod B, and now we're going to create our own pod with overly privileged access, so then we can escape the pod and break out to the host machine. My goodness, confusing, but we're almost to the end of this lab. This part is actually relatively easy to create this. We're going to go ahead and do kubectl apply-f hacksmarter.yaml. I think this is correct. Let's go ahead and see if my syntax works. All right, so we have pod hacksmarter created, and now let's see if we can drop into a shell on that pod with kubectl execute, right? What do we want to execute it in? Well, we want to do it in hacksmarter, and we want to drop into like a bin sh shell. All right, I think we're here, just TTY isn't working. And now we want to go ahead and mount to see if we can get to the host file system. So the way we can do that is we'll mount dev/root, and we'll just say the temp directory. And if we go over to the temp directory, I think we can go temp home cd ubuntu l/la cat flag.txt. And ladies and gentlemen, that is the completion of this lab. There were so many different pieces moving in. I want to jump over to our notes and we'll fill in some of the missing details so far. So if we scroll down to the bottom, we find the other containers used in images. Now what we need to do is we have to escaping the pod, right? And we'll say you create a malicious YAML file and transfer it to the not node. I keep wanting to say node. Transfer it to pod B. And we'll just grab that file that we created. hacksmarter.yaml. Drop it in there. So we have the YAML file. And we will say create the node and drop. Why do I always want to say node? Create the pod and drop into a shell. And we'll go ahead and grab that syntax from up here. So apply and execute into the shell. Create the pod and drop into a shell. Mount the host file system and get the flag. And you can see it right here. We'll mount the host file system. And then it would be cat temp home ubuntu flag.txt. And we'll just say redacted. And that, ladies and gentlemen, allows us to complete this scenario, network diagram and everything included. Now, if you go over to the lab itself, this is the cool thing about Pwned Labs. So definitely confusing, right? And part of the confusion is just because I myself am a noob at Kubernetes. So I'm still learning it myself and learning Kubernetes pen testing. The other part of the confusing is there's so many networks and pivoting going on here. You really have to think through what is going on. But if you are completely new, I want to show this to you guys. Every Pwned Labs lab has a detailed written walkthrough that's going to show you how to do this. So if you get stuck, you can look at this walkthrough. And the other thing I like about Pwned Labs is at the end, there's always a defense, right? So we'll read through this. To defend, we need to start with the server-side template vulnerability. In this case, line 188 contains a variable that passes user input from the web form directly to the render template string. Remember our server-side template injection we got in the beginning? Well, that would have solved it there. Then pod A has that service account attached, which allows it to list secrets, which we were able to get the admin panel secrets there. You can see right there the information or the ability it had to get and list the secrets. On pod B, the internal SA account has cluster admin privileges through the cluster admin binding, which is why we're able to do everything we wanted to any resources we want. So the big idea behind that is the principle of least privilege is something we always need to keep in mind for cloud, Kubernetes, and all of those things. But hey, if you hung with me this long through this entire walkthrough, I mean, we covered Nmap, we covered web app pen testing, we covered server-side template injection, we covered creating character-safe reverse shells, we did Kubernetes enumeration, we set up pivoting with Legolo, we set up reverse port forwarding with SSH. We did some crazy networking stuff in order to solve this lab, but it was a lot of fun. My second time going through it, and I still learned a lot just going through it a second time. So once again, special shout out to Hack and Nefos and the whole team at Pwned Labs for making really such incredible resources, incredible labs for learning this stuff. There is no other platform teaching this kind of thing with this depth and this complexity to help you have a playground to learn in. So thank you for watching, and I will see you all in the next one.